Welcome everyone to this new episode of Tech Talks. Before we start, I wanted to introduce and thank our partner Keystone Certification. We're going to have a little video to play for you. Just a side note, the sound of the video is not really high. So if you can put your sound a little higher, we have a problem here with that, and we can't seem to fix it. So the sound will be a little low for the video only, but we'll start sharing now.
All of us at Keystone Certifications are pleased to be sponsoring Fenestration Canada's NAFS Calculator tool. We hope you'll find the calculator both easy to use and an essential tool for determining code structural requirements across Canada. Of course, after determining the requirements, the real challenge for manufacturers is how to demonstrate compliance.
Keystone Certifications has been helping manufacturers demonstrate compliance using certification since 1998 and now offers a complete slate of accredited programs to qualify fenestration across North America. Demonstrating compliance using certification begins with a complete review of the test reports issued by an independent lab. We verify that the labs are competent to perform the testing, that all necessary tests are complete, and that the ratings are accurately determined in accordance with the reference standard. After successful review, we issue the certificate and now the product to our certified product directory, available on our website at keystonecerts.com.
The essence of certification is the standardized certification label, which is applied to the product at the factory and delivers all the necessary information to demonstrate building code and energy incentive program compliance to building officials, architects, and homeowners. Keystone offers custom certification label printing and prints millions of these labels each year. Ordering certification labels is fast and convenient through the online catalog available on our portal.
So whether you're qualifying your products for building codes, Energy Star, or the Greener Homes Initiative, Keystone Certifications is here to help.
So here you go. Al, up to you for today's topic.
Thank you. And it's great to be back and to be with you all. My co-host and guest today is Dave Goldsmith. And we're going to be talking about the NAFS Performance Grade Calculator again. We had a great talk about that about a year ago, which for some reason wasn't able to be uploaded to YouTube. And so we thought that it was timely to revisit the subject in order to have a video on the calculator, but also because the calculator has been redesigned since it was the last time we discussed it. And so we're going to be visiting what's new and what else you should know about the Fenestration Canada Performance Grade Calculator. What's new and what's different about the calculator? Why did we change the look? Well, it's because we identified a need to rebuild the Fenestration Canada website to introduce new functionality and better integrate it with social media. The new website architecture required us to recode the calculator's user interface from scratch. So the actual calculation engine, you might say, hasn't changed, but the user interface has. This gave us the opportunity to make improvements, add some explanatory notes, and improve the report function of the calculator. The actual input selections that users are using have remained the same. So this is the old calculator. I know I've spent years looking at it, and I get now warm and fuzzy when I look back at the calculator as it looked, let's say as of a year ago or more. This is the new look. The new website has a logo bar across the top. The calculator now appears below that, And we now have the opportunity to have sponsors such as Keystone. And so thank you, Keystone, for being the sponsor of the NAFS Performance Grade Calculator. We really appreciate your support. What's new? Well, the main change has to do, I think, all the panels have changed a little bit, but I'll say previously we just selected the performance class, R, LC, CW, AW. We didn't really understand what was different or why it might be advantageous to use class R. So we've now made it, we've now added the word environmental loads to class R, because we want people to know that if you want to know what is the actual environment required at this particular location, class R is the choice to make. And I've populated the screen just for fun with data from Newfoundland, St. John's, Newfoundland, open terrain, part 9, because this is probably the most severe climate in all of Canada. We think of the West Coast, those of us who live here, think of the West Coast as a severe climate for wind and water penetration, but look at this, St. John's, Newfoundland, open terrain, minimum performance grade, PG 35, minimum water test pressure, 400. Atlantic Canada, you guys must build the best windows in Canada. We're gonna have to find out at the summer conference if that's true. So here's the thing, performance class, we wanted people to understand why class R is often the right thing to choose, even if somebody might want another class, because it tells you something that you don't know when you choose another class. So we've revised note B describing performance class, that even though it's the minimum class in the classification system of NAFS, use the R class to obtain the minimum environmental performance requirements for the specified building and product information. Selecting a class higher than R will get you either a higher value that's required by the class gateway value or the environmental value, whichever is greater. So you'll get the worst case scenario when you choose a higher class, but often you just want to know what it is at the building location. And for that, you want class R. If you choose another class, you could get higher than minimum values. Now, if you have a project where your specification says you need a LC or a CW product, then definitely use the performance class your customer wants with the calculator. What else is new? The report. The report's been redesigned as well. In this case, we see our St. John's, Newfoundland project. We see its minimum performance grade, its minimum water test pressure. The project notes field has been expanded. It has the capacity to put in as much text as you want. So that could sometimes be handy. And it's something, you know, that dealers and salespeople might want to consider printing out the reports for the various market areas that you serve and storing them in a binder or something. You could supplement them in a sales manual. You could also just take the data and put it into a spreadsheet of some kind. But basically, the report function can serve many purposes, and one of them is it's just one simple way to document the different performance ratings required in the areas your organization does business. At this point, we'll just pause to see if anyone has any questions or comments or about the new design of the calculator or your experiences in working with it. Anyone raised a hand yet or anything, Dave?
Not as
you're
of
muted
now.
still.
Yeah, we don't have.
Sorry, I
questions.
was muted.
Yes.
Thanks, guys. Well, I'm not seeing any hands raised. We got one hand raised. It's Sudhir Sharma has his hand up.
Yeah.
So if you could unmute him, please.
Hi, Al, can you hear me?
Yeah.
Good morning. My comment is on this. Is it possible to have the glass thickness tied up to this on the elevation also? Like what would be the glass thickness on a higher elevation, or if it's open terrain or rough terrain?
You know, that would be a wonderful addition to a future calculator, but we don't have the technology to do that yet. But that's a really good question. In fact, I was going to discuss that very topic in just a few minutes further on in this presentation.
Thank you.
Yes, but as a wish list item, I think that would be handy, Dave, don't you?
Oh, absolutely. It'd be a dream come true.
Yeah, yeah. But thank you for the question. So that's kind of an introduction to the interface itself. What else should we know about the performance grade calculator? It's really important to be clear about whether you're in open or rough terrain. I know that many Fenestration Canada members are familiar with this concept, but we've got a lot of new people in the industry, new people in sales, new people in marketing, people who might not be clear about terrain. They might not understand why it's important, when it's important. And you might be in an area in a large city where pretty much everything you sell is in rough terrain, and it's the same performance grade in your whole organization, and there's nothing to worry about. But you might be working also in a company where you've got projects where your products are going to, out of town, in town, maybe on a coastline, and you might actually have markets, or maybe you're supplying a larger network of dealers or customers where you need to, give them specific guidance or actually ask them, where are your projects located, so that we know we can provide you the product with the right ratings. So people do need to understand open and rough terrain. The whole idea of open terrain is you're out in the prairie, or you're by the ocean or by a big lake. There's nothing between you and the wind. Rough terrain is there's a significant moderation of wind pressure. And the code defines the two extremes this way. Open terrain is level terrain with only scattered buildings, trees, other obstructions, open water, shorelines. And rough terrain, you see this suburban landscape abutting the prairie here. I actually took that photo from Google Earth, and I looked for Calgary, where I used to live. We used to live in a neighborhood like this, where we were just 200 yards from the prairie and open terrain. And basically you need about a kilometer of suburban development or woods, forest, extending upwind from your building, uninterrupted for at least a kilometer before you're in rough terrain. So if you're as close to the prairie that you can see it, like this, you're probably in open terrain. And several years back, actually when NAFS first came into the code back in 2012, 2013, I gave a presentation to folks in Penticton just to illustrate this whole idea of how can you tell whether you're open and rough terrain. And one way is to use your online maps, your Google Maps type of application, where they give you a scale on each map that gives you a distance. And if you adjust the scale to where you can see 1 kilometer or 2 kilometers, you now have the ability to do a screenshot and draw some circles. And you can easily draw a circle that's got a radius of 1 kilometer and place it at the center of a building location, such as this one. And because the circle now encompasses a part of the lake, we can tell that it's not in rough terrain. At least from the lakeside, that a building at that location could be exposed to much higher winds than it would be if it was surrounded by more suburban development. In this next location, basically it's all suburbia for the whole kilometer around that location. And so, yeah, you're pretty safe that you're in rough terrain here. Then again, this location here is closer to the airport, and that circle now encroaches both on the runway and the open fields by the highway. And again, you're now in an open terrain situation. Interestingly enough, after giving this presentation, a month or two later, the city of Penticton actually issued a bulletin where they actually said, we don't want people drawing circles on maps and making mistakes. We're just going to tell them what we think is rough terrain in Penticton. And it's actually a rather small portion of the city that they identified as being rough terrain in this area. Now, this is stuff that, anyone can do. This is an example I cooked up for another presentation. I just picked a community in Ontario, Halton, Ontario, generally flat country in this part of the province. And basically, you can just draw a boundary that's 1 kilometer from the edge of the outlines of the built-up areas of the city and have a pretty clear idea of where rough terrain values apply. And outside of that area, basically everything is open terrain. Is this kind of thing you've ever done, Dave, with trying to explain this to people or in your organization?
No, we like to operate on the assumption of open terrain. And when it's in an area that has relatively low 150 hourly wind pressures, using that default gives you a reasonable required performance that your standard default windows will generally have. And many manufacturers, someone mentioned, Sudhir Sharma mentioned glass thickness. A lot of manufacturers, their default glass thicknesses are based on open terrain in an area, and they use tables from the code, historical tables from the building code, that say, for an area, this first table is for an area with 1 in 10 hourly wind pressures not higher than 0.4 kPa. We recently increased the requirement to 1 in 50, but so the default glass tables that a lot of companies use, they don't take into account places like Vancouver Island. And we'll get into that a little bit more later about what the implications are there.
Good point. I think if you're, I think if you're in the middle of Toronto, let's say, or Montreal, or parts of the Lower Mainland, large cities, even Calgary, perhaps, it's quite possible that most of your local area is in rough terrain. But it really depends on the terrain in which you're doing your business. And clearly, if you are serving both open and rough terrain communities routinely, it does make sense to standardize on open terrain as your default, because then you're not going to make mistakes, and you'll be covered wherever you sell, and you don't have to look up each order and figure out whether it's an open or rough terrain. So I think it's just helpful for people to understand the basic tools and the functionality of the calculator. So depending on the size of your organization, you can make the appropriate decisions, whether to standardize on a more conservative value like open terrain, or to actually target different different areas based on their terrain.
Yes, and I think in Canada, because of our history of using A440-00, under that standard, there was a maximum requirement for housing in small buildings, and it was A3, B3, C3. And there was no requirement, if you're doing housing small buildings, to design for any higher than that under the old standard. So people just designed their windows to have a minimum performance of A3, B3, C3, and then it was fire and forget. And so those A3, B3, C3 levels have basically, they're still in the background, kind of the standardized basis of design for typical windows in Canada. Because they cover something like 90% of the circumstances within cities, but they don't cover that 10%. Now that we've got A440S 109, we need to be mindful that sometimes your base window designed to that old standard is not sufficient.
I think a lot of the historically sliding windows, well, actually most of our windows were designed for A3, B3, C3, and that C3 wind load, as you say, covered most of the country, and in a sense it's baked into the design of a lot of products, isn't it? For example, the gutter, the sliding door or sliding window gutter depths historically were designed for that B3 rating, weren't they, Dave? 300 pascals.
Yes, that's right.
And then, of course, when the minimum in some areas, it was either 290 or 330, sometimes the 330 product, products would overflow at 330, right? Even though it was only 30 Pascal difference.
We certainly saw that, so now we have historically designed sliders. They were designed for 300 pascals and a little change in the back pocket. Under the new system where it's 290 or 330, you got more change in the back pocket at 290, but at 330, you're right brimming and very close to overflowing because you originally designed it for 300. You don't have that extra leeway anymore.
The other thing that you need to think about is the height of the fenestration product and to the top of the product. And that's not generally a concern in Part 9 buildings because they're so low to the ground. But of course, many of our members are selling products into mid-rise and even high-rise buildings. And we know that as you get higher in a taller building, the higher you go, the higher the wind pressures are on the windward side, as shown in the diagram on the left. So definitely that's one of the inputs in the calculator. And it's helpful for our members to know that you can use the calculator, those methods, for taller buildings as well. And really, any building that doesn't require like a wind study to determine its wind load. So these are the main parameters: rough or open terrain, height to the top of the fenestration product. But we know the calculator has all these locations. I happened to pick earlier St. John's, Newfoundland as an example. Can a building official tell me to use a different location than my building is in? And the actual answer is yes. You might actually be in a jurisdiction or doing business in a jurisdiction where they feel that the climate data in their jurisdiction in the code is not correct. And the code actually allows local building officials to determine or to either accept the climate data in the building code or to say, no, we have local knowledge and we believe that our climate is more like location X or Y or Z than what's in the building code. An example we know of is Langford, British Columbia, where the building officials in Langford, which you can see located on the left here, have decided that the building code information for Langford for wind and snow and rain is not correct. They believe that Victoria Mount Ptolemy, which is 13 kilometers away, and Mount Ptolemy is a little mountain that pokes up out of the flatlands of Victoria. They feel that that is actually a better indicator of what their wind and rain and snow loads are. And of course, Langford is at an elevation of 97 meters, about 100 meters higher than Victoria, and Mount Ptolemy is at 120 meters. So they probably have good reason for the determination they've made, but it certainly can catch you off guard as a window supplier if you just assume that a particular municipality is defaulting to the code values. Most cases they are, but it does happen where they do not. Here's just a look from the Google Earth. Pretend you're in a helicopter and we see Victoria Mount Ptolemy to our left here and Langford off in the distance. So is the calculator mainly for Part 9 buildings or can it be used for all buildings? The Canadian supplement can be used to determine performance grades for Part 3/Part 5 buildings that do not require a wind study. And when would a building require a wind study, Dave?
Well, I would say if it's surrounded, if it's like a high-rise building in the middle of a downtown location, surrounded by other similar buildings that have unusual shapes, then you can very definitely wind up with extreme wind conditions that are not accounted for in the Canadian supplement. I would give you an example. In downtown Calgary, there are these huge decorative vanes on 8th Avenue downtown, and they're not purely for decoration. It's because people were getting blown off their feet on wind gusts on Stephen Avenue Mall. And it was because of the way the local buildings were funneling the wind in that area. And they put these decorative objects that most people assume are art, that were quite high standing, in order to break up that wind flow.
That's so interesting. Wow. Yeah, so it's just an indication of how winds can be influenced by the man-made objects that we've put together
so definitely
in various ways.
High rises downtown surrounded by other high rises. Yeah, you do require a wind study for sure.
So it's interesting that, typically you can rely on the values of the Canadian supplement for the projects you're working on, but you do need to be aware that sometimes that may not be the case. And, I think the companies that do the high-rise work are probably more familiar with this, this running into this issue. What is also interesting is that the Canadian supplement is now referenced in Part 5 of the Building Code for the category of product called other fenestration assemblies. So in fact, the code actually now tells you, and this is the 2015 National Code, it tells you to use the methods of the Canadian supplement to determine the water test pressure for fenestration products, not just in small buildings, but also in large buildings and high-rise buildings. It tells designers that they should be using the methods of the Canadian supplement to determine the water ratings for the products, whether it's window wall, curtain wall, slope glazing systems, things like that. So it's interesting to realize that the information that we've presented to you in the calculator is actually suitable for a wider range of products than just the residential window industry. Here's the question that our caller had. Can I use the calculator to design the glass in my windows? Dave, do you want to maybe touch on this?
Yes, you can. Keeping in mind that if you're using ASTM E1300, you can't use the 0.75 factor, and when you're using 1220, you can. And so I use a calculator that's based on 1220 that is published by IGMA. And so it will give you, based on an input from the output of the software, it will give you the strength of the glass, what its capacity is, and it'll also give you the deflection of the glass. And it warns that deflections greater than 18 millimeters may be of a concern. So as you know, Al, tempered glass is very, very strong, but is not any more rigid than annealed glass. And so designing with tempered glass, say you're tempering the glass for reasons like you need them to meet guard loads, the calculator will tell you, oh yeah, this is at 50% of capacity, but the deflection might be something that's not going to be acceptable to the customers. And we have encountered this on a number of occasions on Vancouver Island. And it's because most manufacturers that are mainland based or Alberta based, such as in our case, are using glass area versus thickness tables that are based on climatic data that is like, say, 2/3 of what you would get on Vancouver Island.
Right. In other words, if your default glass values are designed for more of a rough, a less extreme climate than the coast, then you may run into deflection issues on the coast.
So where I start to get concerned, if I see greater than 1 kPa design pressure, you're getting into the area where your standard glass thickness schedule may not suffice at the higher permitted areas for 4 mil and 5 mil and so forth. And you really should be doing an analysis to determine what the strength and what the deflection is of that glass in order to avoid any customer complaints.
So, Dave, speaking as an engineer, you know exactly when you could or couldn't use the values from the calculator. Dave and I collaborated on a paper we presented to the Fenestration Canada Technical Committee, showing how you could go from the calculator's output values to a design pressure for glass design. And we're actually going to formally discuss publishing that paper at the Technical Services Committee. But for the moment, it's been published as a discussion paper at the committee. But basically, just taking the design pressure value from the calculator is not, you can't just use that as the input with ASTME 1300 or even with a CGSP 1220. It was my understanding.
Well, that is correct.
You had to factor it before you could use it.
You did have to factor it, and it just so happens that the software, the IGMA software I referred to, which is called GD 2012, does factor it in the background. But if you were to use that in conjunction with the paper standard and not factor it according to the Part 4 load combination factors, you would be deceiving yourself as to the glass strength.
Right. So basically, don't assume that you can take your design pressure value from the calculator and go directly to a glass design calculation. The paper that's going to be published will actually provide guidance of how you would factor the load to use it with the appropriate calculation method. But we're not at a point yet where we can provide you the guidance. Yes, you can go from the calculator to the glass in this one step. Now, can I use the calculator on terrain like this? This is a really interesting example that Dave brought to us, because if we look at the Canadian supplement, it tells us that we can use it on level terrain. We only have to be worried about whether the building is on a slope. And so somebody looking at this site in Calgary might say, okay, open or rough terrain? It's open terrain. Is it level? Yes, the homes appear to be on level ground. Does the building official allow us to use the calculator, the Calgary data in the building code? Yes. So are we good to go to design the glass, or actually to determine the performance grades for the windows at this building site? And you would think, I guess we are. But are we, Dave?
Oh, we found out the hard way that you are not. So we supplied 2 of the houses that you see in the foreground, 2 or 3 of them, and the rest were supplied by other fabricators. And basically all of those houses that you see in the foreground, after 10 or 15 years, and these would have been late 1980s or early 1990 projects using wood windows, they were starting to leak. And the reason they were starting to leak was probably because of excessive deflections due to wind speed up over hills and escarpments that were affecting the very large picture windows that were overlooking the scenic valley and causing the wear and tear on the sealants that wound up resulting in leakage. So this whole row of homeowners basically hired a consultant with a view to investigating whether or not these windows were code compliant, probably as a precursor to seeking compensation for the required window replacements from the window fabricators. However, these were permitted under the old A440 system, where again, it said to be code compliant, you need to be A3, B3, C3 and no more in housing in small buildings. And it did not take into account or mention anything about wind speed up over hills, over escarpments. So they were code compliant, but they were not in fact sufficient for the challenges of the wind loads that they were actually going to experience.
So this development was built in the 80s, I guess, before before the code addressed this kind of a wind condition. Is that right?
That is right. And when the investigator talked to me, I explained how the code worked in the 80s and explained how it works today, and basically said that even today, if you were not cognizant of the wind speed up over hills and escarpments, and most users are not selling into Part 9, you know, they consider all Part 9 buildings to be basically the same thing, you know, you would still wind up with a similar result, not being cognizant of basically what we're presenting here today, Al.
Yeah. So, you know, we're basically bringing this image to you to draw your attention to the fact that there is something called wind speed up over hills, and essentially conditions like this are outside the scope of what you can use the Fenestration Canada calculator to do. And it's not that the calculator has a problem, it's just that the Canadian supplement doesn't address these conditions. These are conditions where you actually need to get an engineer involved to examine the specific size and shape of the hill and other factors to determine what the actual wind speed would have to be. So you really need to be aware that even though the methods of the Canadian supplement apply in most cases, there are cases where they don't. And it's really important to know when that is. So the Canadian supplement itself tells us that the simplified procedure used to calculate the specified wind load applies only to buildings on level terrain having a slope no greater than 1 in 10. And then it says for buildings that do not meet this criteria, buildings on steeper slopes, hills, or escarpments, wind load values are calculated in accordance with the structural commentary requirements of the National Building Code. So we really want all Fenestration Canada members to be aware that that you need to know when wind speed up can be an issue. This is a cute diagram. It's a rather old one, but it illustrates the fact that if you're out on something like the open sea or the prairie, you're dealing with an open terrain, pretty high wind pressure. And as you come closer to land, as you have trees and buildings, rough terrain, that rough terrain over a distance of, let's say, 1 kilometer or so, can significantly reduce the intensity of the wind at lower elevations. As you come up to the top of a steeper hill, you can experience a significant increase in the wind speed that actually becomes much higher even than the open terrain kind of wind that you would encounter. And of course, on the other side of the hill, assuming the wind is always blowing, you know, from the ocean towards the land, on the other side, the leeward side of a steep hill, you could actually experience a significant reduction in the wind pressure. The point of all this is to say is that it gets complicated when you start having hills. But the guidance, when should we worry about it, has been kind of lacking. As we saw what the Canadian supplement told us here, having a slope no greater than 1 in 10. So let's say you are on a gentle slope of 1 in 10 or 1 in 12, and or 2 in 10, but at what point is it a problem? Is it a problem at the bottom of the slope? Is it a problem at the middle of the slope? Is it a problem at the top? The Canadian supplement didn't give us any guidance in this area. And so several years ago, to solve a different problem in Alberta, a document was created by Canadian Home Builders Association. And long and the short of it is that at the time, well, anyway, let's just say that they needed an engineer to calculate the appropriate performance grades for Alberta in 2014. And one of the things that the engineer did is that they clearly addressed the subject of wind speed up over hills. And they basically made it clear that it's the buildings that are sited on the upper half of an isolated hill, ridge, or escarpment that constitutes an abrupt change in the general topography. may experience wind speed up leading to increased wind loads. So we saw the example that Dave described. There was an abrupt change in the landscape. There was a steep slope, and then it turned into a plateau. And that would be the abrupt change in the landscape that could trigger a higher wind pressure. But the engineer went on to say this is only a concern when the buildings and other site conditions and the location of structures meet all of the following conditions. And it further laid out the specific conditions. At this point, this document is not widely available. You know, we have, Dave and I were both involved in this project at the time. We both, you know, we have copies of it, but it's no longer available from any public source. And so this is a problem we're going to try and tackle here for Fenestration Canada. But for now, we want you to know that you do need to be worried about, the upper halves of hills. You do need to be worried about escarpments. And you need to know that the Canadian supplement doesn't answer those questions for you, and neither does the calculator. So this,
I just want to point out, Al, that like this is the kind of thing that gets brought up whenever building officials are made aware of the detailed code language. So that working group that we created for Alberta, it was initially struck to deal with the fact that A440 S108 was generating generating specified water resistance values that were excessive for low-rise buildings. So we formed a group that was myself, yourself, Canadian Home Builders Association, and City of Calgary Building Regulations Division, Alberta Building Officials Association, and City of Edmonton Development Services Building Regulations. And when they see wishy-washy language like we've just covered in A440 S1, they're going to say, we're not going to accept a table that is calculated in accordance with A440 S1 unless you can provide guidance for when A440 S1 does not apply. So this was a prerequisite to us creating that table for Alberta that was similar to the table that had been created in BC and went live in an update to BC 2012 to avoid some of the problems that they had encountered in BC. We didn't want to experience that again in Alberta.
And so we basically want our members to know that when you need to be worried and when you need to realize that you're going to need more than just the Canadian supplement to deal with wind pressures. And we're going to try and work with an engineer to help us to provide guidance in a future update to the calculator on defining more clearly the conditions when the use of the calculator would be problematic. So, but at least we felt we should give you this much information just to make sure you don't get yourselves in hot water and are aware when you should be concerned about the limits of what you can do with the calculator. Any questions from or comments from our viewers? Dave?
I'm not seeing any hands up, but let's give them an opportunity to raise their hands, and we'll go from there. So Jim Thring has his hand up.
Hi,
hey,
Dave
you're
and Al.
unmuted. Hi.
Can you hear? Hi. It's a simple question, and it was from the beginning of the presentation, and maybe I missed the source. Al, you were talking about open terrain, rough terrain, and the 1 kilometer rule, and the example of Penticton. Where did that 1 kilometer come from?
So that comes from the definition of open terrain in the building code.
Very good.
And we, I guess if I backed up a number of slides here, we could get back to that definition. Here we go. So this is how open terrain is, rough terrain is defined, right? Open terrain is you're out exposed in the open. rough terrain is suburban, urban, or wooded terrain extending upwind from the building uninterrupted for at least 1 kilometer or 20 times the height of the building, whichever is greater.
Great. Perfect. Okay,
So,
I missed that, Al. My apologies.
oh no, that's fine. I mean, it's a lot of content here, and it's easy to miss something like that. And so, in the code, you can actually calculate an in-between terrain, but between open and rough. But you basically pretty much have to be an engineer to know how to do that calculation. So.
Well,
For the rest of us, we should just stick with the 1 kilometer of suburban, urban, or wooded terrain. So it could be a mixture of trees and forest and buildings and so on.
sure.
And you know what? So I have done that calculation, and it's actually 100 meters from the shore, 200 meters from the shore. You know, let's say on the shore is an exposure factor of 1. Rough terrain is exposure factor of 0.7. It's actually 0.7 doesn't start to climb towards 1 until you're within like 300 meters, 200, 100 meters of the shore. So in a large project where this kind of thing is critical, if you can get the specifier to accept an intermediate terrain calculation, you might be able to get away with less thick glass and less strong reinforcing for the project. So far, all the specifiers that we have dealt with have not been prepared to accept anything like that. The specifiers tend to be very conservative, and building envelope and engineers tend to be very conservative, and they don't want to hear nitty-gritty arguments like that would reduce the requirement. But that might not be the best thing for the customer on some jobs where it really isn't warranted to use the full 1.0 when 0.8 might be the intermediate terrain calculation and result.
Right. Well, thank you for that. I really appreciate it.
And the code is very clear that you can calculate this intermediate terrain. So for example, this sentence, NBC, National Building Code 4.1.73.5, actually, makes it clear that you can calculate the intermediate terrain value. And I think, I think, Dave, if the it's possible that maybe if the building officials were actually presented with the specific code language, they'd be more comfortable with the intermediate calculation.
I think they would be, but they would definitely want that calculation to be performed by an engineer, in which case you really would need a supporting registered professional signing and sealing, shop drawings, and letters of assurance. And so a lot of projects don't have that, and they don't want that.
Right,
but absolutely, if you ran into the situation where it's going to cost you $50,000 for the glazing upgrades, but only $5,000 to get a supporting registered professional for the project, that would definitely be something worth considering.
Words for the wise. Any other questions or comments from our viewers today?
We don't have anything as of now.
Okay.
So Al, if we have like 12 minutes left, if you like, I have an example of wind tunnel testing that I could share with the group.
That'd be very interesting.
So if you stop sharing and allow me to start sharing, we'll do that.
It's all yours.
Hey, okay. So can you see my screen? First, let me get rid of my, hold on. I'm not trying to leave the webinar. Okay, so you can see my screen, right?
Not yet.
Not yet. Hold on. Share screen. Screen 2. Share. Okay, excuse me. Okay, now you can see my screen, right?
Ah.
So this is a wind tunnel test for a project in downtown Edmonton called Station Lands North. And the building in question is the red building here, and you can see that it's in the middle of downtown Edmonton. There is their new stadium for the Oilers hockey club there. And this is the building in question, and these are the surrounding buildings. And so this is a turntable that allows them to investigate the worst case scenario for wind coming from any of the cardinal directions. And so there's our little building there. And again, a view of the turntable. and a closer view of the building. And this thing is full of pressure sensors that come through a wiring harness from below to detect the actual suction and or pressure applied to the building. And scroll a little bit more. There's another view of the building in question here. And there's going to be other stages, by the way. So you can see this is the first stage. So they investigate, this is the first part of the building that's going, and this is going to be for future development. And here it is with that part of the building alone and without this future development tower. And this is the location downtown Edmonton here. And if you were to Google Earth it, you'd see you're very near to the river valley. So this was the results of the wind tunnel testing, and it's giving you the pressures, the highest pressures in kilopascals. And you can actually see counterintuitive to what structural commentary does for simplified on the static method. It's not necessarily the top floors. It tends to be the corner windows in areas such as this. So our highest pressure, 2.75 kPa on this building. And so, yeah, so if wind tunnel testing were not being done for this building, probably the structural commentaries would not have come up with pressures that are quite that high for the corner windows that are partway up the side of the building. So, and they did it from all of the different sides, and I just went through there and I looked for what the maximums were. Here's the maximums were from all of the different sides, and that number there on the very first illustration was the very highest pressures. And we checked that our glass strength and our mullion deflections in our quote were going to be sufficient to bear those pressures for the windows that were in that part of the building. Very important, because one of the worst things that you can have happen is to quote a very large building like this with probably a window package, you know, costing in the millions of dollars. Being unaware that this is happening in the background, you quote the building, you win the job based on a naive set of assumptions, and then the shop drawings come back from the supporting registered professional and they say you need to go from 4mm glass to 6mm glass on the windows that are here, and your mullions need to be extraordinarily heavily reinforced on these windows. Well, guess what? You have won the project based on your original quote. The bank loan has been taken out, the budget has been set. That's all there is, and there ain't no more. And now you are not going to make a profit on this project because you're going to be, you know, comping your customer, the builder, for all of these 6 mil improvements that come out of your in pocket, but nobody else's.
So it appears that in the wind tunnel study is identifying risks that might not have occurred if this building was out in the open somewhere, right?
Yes.
In other words, some of the wind flows here might be partially due to surrounding buildings and sort of wind rivers that might be flowing in between these various towers to create unusual conditions that you would not be able to determine just by conventional
That's
engineering.
correct. And I think they even took into account, you know, these are the current buildings surrounding it, right? But what kind of buildings might appear at some point in the future, and took that into account as well, I believe. You know, so they want to be conservative in all of this because you are in a critical situation downtown, and in particular, you've got a huge building right beside you. You know, that might be creating a Venturi effect between the two buildings that can result in really extreme wind speed ups. But that's the science of it. If you want to, if it's an important enough building, critical enough building, that's what you really need to do.
And I think folks that are bidding on projects like this, you were probably notified of this approach to the wind tunnel study?
Oh
is
no,
that right?
of course not. Oh, of course
no?
not. The very first time we quoted this, well, we quoted it twice.
Okay.
And the first time it was for a different contractor, and we quoted it naively. And then the project was delayed, and a second contractor came in, and they provided this information. We went, oh, holy shit. You know, that would have been nice to know. But you know what? Like before any of this study was done, somebody wanted us to quote the windows. And thankfully, that's not the contractor who got the job, because we could have found ourselves very easily in that situation, having quoted it, won the job, and now, oh, here's a report from a consultant engineer, and these are the wind pressures that you need to quote to. That would become a tough conversation for sales management to have with the customer and internally on what this is kind of a prestige project. If we get this one, believe me, we'll be bragging about how our windows were good enough for a particular type of windows that are most strongly reinforced are good enough for a building like this with wind tunnel testing.
Potentially, though, in that first case, you could have qualified your quote that it's based on conventional wind loading, as described in Canadian Supplement or something like that. And the would not apply if higher loads were to be required on the basis of a wind tunnel study, right?
Mm-hmm. Yeah, and I think that's what we did when I did an original config review. It was all building height and the structural commentaries, and basically using the simplified method that is from structural commentaries. That is an A440S1. But those were going to generate pressures that are much lower than the 2.25. They probably would have generated pressures, excuse me, sorry. Went too many slides down. They probably would have generated the pressures that, oh boy, where'd we go here? Like that were at the top of the building when we first looked at it, like the 1.75. Oh, and here's a nice illustration here. This is what these buildings look like, what these pressure sensors look like. There's a wiring harness that goes in. This was the building in that case. Wiring harness that goes in that has openings at every window location and goes to a data collection box like this. So it's very detailed data. And also they have to take into account the size effect and have a multiplier for the size effect. Because obviously at this scale, the wind is not as viscous as it should be to represent the scaling factor on a building. Doing small scale buildings, I mean, sometimes they might run water across instead of wind, but you need to account for the scaling factor in engineering.
Quite the science, quite the science. Any other comments from our viewers?
No questions for now.
Okay. Well, thank you everyone for spending some time with us today. We got some bonus information here from Dave. Thank you, Dave. I think really it's helpful for people to appreciate that in this industry, we could be dealing with buildings where very simple tools, such as the, Canadian Supplement, are there to provide guidance to prevent problems, Dave, that your company and others encountered on that ridge in Calgary in the 1980s. That was a time when there was insufficient code guidance to address that problem or pay any attention to it. Today, I think viewers of this session today would know that if they were to run across a ridge like that, they would be concerned about the potential for much higher wind loads than they would otherwise expect to exist in a place like that. But of course, there are even more challenging conditions you can run into with high-rise towers in our cities. And so definitely it's good for, I think, everyone to appreciate that wind is not just a simple matter. And in ground-oriented buildings, it's not often a problem, but it can be in the wrong terrain. So thank you, Dave. Appreciate your joining me on Tech Talks today. Thank you to all our guests. Thank you to those who did have questions for us. And we'll see you again in a future Tech Talk.
Thank you.
Thanks, Al.